So in this video, we're going to talk about quadratic inequalities. And before we can do that, we need to remember what an inequality is. So when we talk about basic inequalities, the things that you remember from middle school are these symbols here, right? Are greater than, less than, greater than or equal to, less than or equal to, anything that is not a defined equals, right? So if I have x equals 3, that is one solid point at 3, whereas x is greater than or equal to 3, that can include 3, that can include 4, and so on. And the same deal with if x is less than or equal to 3, it can include 3 and anything less than that, and so on and so forth with these two other examples. Keep in mind the direction is different depending on what the inequality is, and also if it's an open circle or closed circle, which means does it include the value or does it not include the value? So let's talk about the quadratic part of a quadratic inequality. Remember, the general form of a quadratic function is f of x, which is our y, is equal to ax squared plus bx plus c, where a, b, and c are some constants. What we're used to solving for are the roots, or where the function f of x is equal to 0. So that's where that intersects the x-axis. So remember, the discriminant will tell us the type of roots, and we can do a lot of other operations with that. But if it's set equal to 0, that is where it's going to definitely intersect the x-axis, if it does. Keep in mind some functions will not. Now, the inequality part comes for when I set this function greater than or less than to 0. It could be greater than or equal to, or less than or equal to as well. But if I have some form of a greater than 0, that means that it is all the points on that function that fall on the function above the x-axis, right? Because if the function, or y, is greater than 0, it's going to be above the x-axis. Conversely, if it is less than 0, it's all the points on the function that fall below the x-axis, because that means that the y is negative. So let's take a look at our first example. We have a quadratic function that is less than or equal to 0. And when I solve for x, it's not just going to give me one or two possible values, it's going to give me a range of values because of that inequality symbol. So the first thing I'm going to do actually is set it equal to 0, because I know how to solve for those. So I'm going to factor that out. So what I get here is x is equal to -2 and x is equal to 6. So I know that those are going to be the roots of my function. That's where it's going to cross the x-axis. So now I have to consider this here. And if I actually graph the function, I see my two roots at -2 and +6. And what this function is asking me to find, or what the inequality is asking me to find, is all of the values of x where it is less than or equal to 0. And if I remember from what I just learned in the previous slide, that means that where it's going to fall below the x-axis, or where the y value is going to be negative. But this one includes 0. So I know that that's going to be true where x falls between -2 and 6 on the x-axis, and it's going to include those 2 points. That's using set builder notation, and I can also express it using interval notation with our brackets between the -2 and the 6. And for our second example, we're going to follow the same process, but as I'm looking at this, I know it's a quadratic, with the exception of that all of the terms are not on the same side. So that's the first thing I'm actually going to do, is I'm going to move the 3x plus 10 to the other side to give me x squared minus 3x minus 10 is greater than 0. And I'm going to do the same thing as I did in the last problem, where I'm actually going to set it equal to 0 so I can solve for the roots. So when I solve for the roots of this function, I get x is equal to -2 and x equals 5. And if I graph it, I see that I have roots at -2 and +5. And this function, this inequality, is asking me for where it is greater than 0, if I remember from a couple slides ago. That means that wherever the function falls above the x-axis. So that is going to include all the points here and all the points here. So essentially, all of the other points with the exception of what falls between the -2 and 5. And I write it like this. So x in set builder notation is less than -2, or x is greater than 5, which satisfies these two ports. Or in interval notation, -infinity to -2, which is approaching here. Remember parentheses because it's not going to include this point because there's no line underneath the inequality symbol. Or 5, so it's going to start at 5, again, parentheses, not brackets, to positive infinity. And for our last example, let's take a look at x squared plus x plus 1 is greater than 0. So obviously the first thing I'm going to do is I'm going to set this equal to 0 and try to see if I can factor it. And unfortunately, I can't find a way to factor this that is going to suffice my equation here. So I'm going to pull out my trusted discriminant, and I'm going to plug in my values for b squared minus 4ac. What I notice when I do that is I get a negative number. So that means that there are no real roots. That doesn't mean that there aren't roots to this function, it's just that they aren't real. They're not going to touch the x-axis. So if I graph the function, so now I notice that there is a minimum point and there are some roots where it actually will hit the y-axis, it just will not cross the x-axis. So the inequality here is asking for what values of x will this entire inequality be greater than 0. So thinking back a couple slides, that means when it is above the x-axis. And luckily enough for us, the entire function is above the x-axis. So that means that x satisfies this function where it is all real numbers, or it's from -infinity to positive infinity.
And that's going to do it for this video. Thanks for watching.